Coroutines. Coroutines are basically like, I don't know how you could possibly make a game without coroutines once you know they exist, because they are very, very, very useful. What are they? They're not Unity specific apparently, but I associate them with Unity. I don't think there's a version like there's probably an equivalent to Unreal, but they're not called coroutines, I don't think. But basically, they're special functions that run over like multiple frames, and you can like give them the amount of time that you want them to run for. So basically, um, very useful for anything timed, anything to do with like timers or like lerping values. Coroutines are your best friend for this. But something to note is that it's not the same as threading. Threading is when you're having, like multiple threads at the same time, obviously. Like that is different from coroutines. Coroutines all run as part of the main thread. So, that's very important to note is that, I don't think Unity even has threading. Coroutines are not threading, but they're very similar in terms of functionality. So again, why would you use coroutines? Because if something happens over a period of time, uh, some people will make timer variables that they'll update in the update function in Unity in a mono behavior. That's terrible. Please don't do that. I mean, you can, and there's probably benefits to doing so, none that I can think of off the top of my head. But basically, you're clogging up your code. You're making it very unusable when you can just have a coroutine for it instead. Um, Coroutines don't just help you do like timer functions. A single coroutine can also represent a sequence of events because you can pass it multiple timers, basically. You can make it wait for multiple different periods of time and then have it execute things once those different waiting periods are up in order, which is very, very useful. So you don't have to make a whole bunch of different functions for one sequence of events. You can also like start and stop them very easily because you can do things like assign coroutines to variables. Like you can have a coroutine variable and you can say stop this variable and it'll stop the coroutine, which is very, very useful. So let's take a look at a coroutine here. This is a coroutine in Unity. This is off Unity's website for like their coroutine documentation. Coroutines have a special return value called IE numerator because it's enumerating over time with its time value. So basically what's happening here, the return type, IE numerator fade, that's the name of the coroutine. If you want it to be a coroutine, you have to use IE numerator basically. Or I think IE numerable, I don't know. I always use IE numerator. So here, it's got like a color that it's lerping the value of over time. So this is, a for loop. And if you're familiar with for loops, basically it says, increment this value and, for every incrementation, do this thing inside the for loop. So in this for loop, it's changing the alpha of the color. And then it's setting that new color value to the renderer's color. What's important here is this statement here. This is kind of unique to coroutines, is this yield return null. So basically what it's saying is that, so like in a regular function, right? This for loop will run all at once over like a single frame, basically. It'll do the whole calculation over the single frame. What this yield return null is doing is saying, wait, don't do the next part of this for loop until the next frame. And so it'll do it over however many frames it takes for the for loop to increment, which is super useful, basically. So it's basically turning this from like something that happens all at once into something that happens, over however many frames it takes to get it done, which itself is pretty limited, but I think you might be able to see how useful that could be. Like instead of just doing a for loop where it's like an alpha value that you're decrementing with like 0.1, you can use delta time to set it as a timer variable and say like for X amount of seconds, basically do this thing. So that's very, very useful. But there are other ways to do that. So like, yeah, if you want something to happen over a certain amount of time, like lerping, you want to do your for loop with a delta time. But there's other applications, other things you can do with a coroutine. But finally, calling the coroutine is pretty easy. You just use the this static function start coroutine, and then the name of the coroutine. So that's the most basic way to start a coroutine. Once you've made it, we have our fade coroutine here. Then you start your coroutine however you want to. And this is using the old input system, but obviously I think it's pretty clear how you'd use this with the new input system if you know how that works. Time delays. So that's another way. So you can obviously make something happen over a set amount of frames or over a set amount of seconds if you're using delta time, like divided by a value. But instead of returning, yield return null, which is saying wait for the next frame, you can say wait for seconds to, you pause the coroutine for that amount of seconds. And wait for seconds is affected by time scale. So if your game is paused, if you're pausing, like setting time scale to 0 to pause your game, then the coroutine will also be paused. So pretty useful. And if you want something to run, while the game is paused, like let's say it's something for UI, then you just use wait for seconds real time, and then it's not affected by time scale. Super duper simple. So yeah, like here, this yield return new wait for seconds 0.1. That just says wait a tenth of a second and then do the rest of the coroutine. So very easy. And like I said before, you can chain these together into a sequence, right? So you've got your basic coroutine that's like, okay, do this over X amount of frames in this for loop. And then you've got your coroutine that says, wait for X amount of seconds and then do this thing. But then you can have a coroutine that's like, do this for X amount of seconds, then wait for X amount of seconds, then do this, and then wait again, and then do that. So you can do a whole sequence of events in one single coroutine. So some extra things, like I said before, coroutines can be assigned to variables. So that way you can start and stop them a lot easier. Like stopping a coroutine, like you can stop all coroutines at once if you want to. I don't know why you'd ever really want to do that in a script, but you can do it. Or you can like with this variable, like you can stop a specific coroutine that you started, which is very, very useful. Because otherwise, I don't think there's any actual way to stop a coroutine that's been started if you don't save it to that kind of variable. But yeah, as you can see before, here it says, coroutine equals wait and print, and then it's got it, passes in a value, which I'm guessing is like the amount of time it's waiting for. And then it just says, start coroutine, and then it uses the name of the coroutine variable instead of the name of like the coroutine method. So yeah, if you're familiar with lerping, linear interpolation, like in that example with the color value, I don't think like this isn't actually a lerp, but it's a similar principle. In your for loop, your incrementation value can be used for lerping things in a coroutine, which is very, very useful. And that way you're not making that nasty update timer that's getting incremented in update and lerping an update. It's so much nicer. So yeah, that's coroutines in a nutshell. Pretty quick. Anyone have any questions about the way coroutines work or any specific examples they'd like to run through?
If you have it set to like return null or whatever, does it just like do it every frame?
Yeah, you'll return null is saying stop right here. Don't do anything else until the next frame, and then it runs the next stage of the for loop basically.
Okay, gotcha.
So yeah, just to reiterate, a normal for loop, if you make it in like a regular method and you call that method, it'll run the entire for loop in that single frame that you call it on. So like if this were not an IEnumerator and you didn't have a yield return null in here, you wouldn't see it like change color over time. It would immediately be at like the maximum color value from the end of the for loop in a regular method. But here in this coroutine, because it's pausing every frame and then not doing the next part of the for loop until the frame after that, you'll actually see a change over time. Any other questions? If people want, I can even pop open Unity and we can try a for loop of our very own. Or like not a for loop, a coroutine. This is the coroutine presentation. I sure hope you all know, well, I mean, you don't have to know how for loop works, but But yeah,
That sounds like fun.
yeah, okay. Give me a second here and we will get into Unity then. If nobody has any more questions. For loops, you don't necessarily need a for loop for a coroutine. It's just one application of a coroutine, especially if you want to do something on a timer. So let me see here. We're going to be hopping back and forth between Unity and Visual Studio, so bear with me here. Okay. Here is our basic Unity scene. Nothing in it, so let's add a plane because this is nasty. Okay, let's see. Yes, 3D object. We'll add a plane here. Here's our wonderful plane. I don't even know where camera is. Yes, main camera. Where are you? All right, tilt that down. I'm doing my nasty. That is not how that works. Yes, okay. So now we can look at whatever's on our plane here. Wonderful. We'll zoom in a little bit because this is a professional presentation. Okay. So we have our view of our plane here. Now, here's what we're going to be doing. We're going to be moving a box using a coroutine. Right, so we have our cube here. Let's get our cube up here. And let's change its color. Yes, okay. Coroutine cube. All right. We're doing it very nasty style. We're going to just make a material and put it right here. What color do we want the cube? Whoever speaks first gets to choose the color of our cube here.
Orange.
Orange. Thank you, Ellen.
You bet.
Okay. Awesome. We have our orange cube. Let's make our floor blue, just for color theory reasons. I don't know why I just made a lens flare. That'll be in the project. Floor. Right. So, okay, awesome. Floor. So we will make a new script on our cube. Right. And we're going to call it coroutine move. Yes. Oh, yeah. Oh, that's right. It has to be camel case. I work in Unity. I'm working on a game in Unity. So we're going to pop that open. And then I'll switch to sharing Visual Studio. Okay. Let's see. I'm going to stop sharing for a hot second here. And then we're going to switch to, hello, where's Visual Studio? Okay, there it is. Awesome. So can everyone see Visual Studio right now?
Yes.
Awesome. Okay. So we're going to make some variables here to do what we want to do. We're going to create a private transform. Actually, we're going to do vector3. Private vector3, yeah, position. Okay. I don't even know if we'll need this. I'm a very scatterbrained coder. Okay. Well, we'll actually go ahead and make our coroutines. Like I said before, we need our IE numerator here, and we're going to call it, we're not going to call it coroutine move because that's the name of the script. So IE numerator move over time. That's what we're doing here. And you'll see when you make a coroutine that it gives you the red squigglies because it needs you to return something. So for now, what I like to do when I first make a coroutine is I just pop a yield return null in there, even if I want it to be on a timer, because that way it stops yelling at me and I don't like being yelled at. Okay. So we'll probably add a for loop in here over time, right? So, we'll do public because we're lazy. So we'll do a public float move time. Okay, awesome. And yeah, I know what I wanted this vector3 for. It'll be our final position. Awesome. And then we'll have our also a start position. So private vector3 start position. Awesome. So I think these are all the values we're going to need. So then we're going to say here in start, okay, so setting up movement values. Awesome. So we'll say our start position is transform So if you're not familiar with Unity, if you just use lowercase transform, that's a transform of the game object that this mono behavior is attached to. So transform.position is our start position. And then our final position will be start position. Yeah, we'll do something nasty. We'll say it's a new vector 3. Don't do this, please. No, there's probably better ways to do this, but this is what I'm doing. So actually, yeah, let's do this the not so nasty way. So we'll say float new y. I'm very scatterbrained right now. Okay, float new y. We're making a new float here and start is equal to start position dot y plus 4. So we're going to move 4 units up here for our test. And then we'll say that final position is equal to start position. And then we'll say final position dot y is equal to new y. Okay, so final position and start position are set up. Hooray. This is probably not the best way to set it up, but now in move over time, if we want something to move over time, also, let's just go ahead and set up an update when we want move over time to start. I think this should be using the open input system because it's a fresh Unity project. So if input dot get key down, hello, input not, what the hell? I'm Unity knower. Is it get button down? That's not right. Yeah, there it is, get key down. Awesome. Get key down, key code dot u for up, because we love control schemes that make sense. Awesome. Why is this nasty? Oh, it's because I capitalized the I in if. Again, I'm a professional programmer. Then we're going to say start coroutine. We're just going to do the basic method for now. Start coroutine, move over time. And I'll show you why you want to use coroutine variables, because then we'll say stop coroutine, move over time. And also just to test something that I have a hunch about. Right, so we're going to immediately start our coroutine every update frame, basically, is what's going to happen. So then, in move over time, we have our transform.position, right? So we're going to make our for loop. So for, and instead of an int, because most of the time for loops use ints because you're usually iterating across like an array of something, but we're not doing that. We're using it as a timer. So we're saying float I is equal to 0 for now. I plus equals time dot delta time, and we'll say this will take 3 seconds. So divide by 3f. Well, yeah, that's our last value. And then we'll say I is less than 1f, right? So basically this will make something happen over 3 seconds, this for loop. Okay, we're going to say transform.position is equal to vector 3 dot lerp start position, end position, or is it final position? Yes. And then I. So I will be our alpha value for our lerp here. And then we'll take our yield return null and we'll stick it in here. So now our move over time coroutine is ready. So if we hop back over to Unity, this should be ready to go. Let's see here. And again, if anyone has questions or would like to point something out or would like to see something done with coroutines, please feel free. So we have our value here. I hate the stupid thing bar. Oh, yeah, I made a move time value. We're not using it right now because I'm lazy. And I just hard coded it. Don't hard code your values, please. Okay, so if I press U for up, wow, it took 3 seconds to move up 4 units because that's what we coded it to do. And as you can see, even though in update, I say stop the coroutine every single frame, every single update, the coroutine still ran. Now, why was that? It's because we didn't give it a variable. The coroutine just started on its own. So when you say stop the coroutine, it doesn't know which one it's supposed to stop. So let's go back to Visual Studio and correct this. So back up at the top, we'll get rid of our useless move time thing because hard coding is perfectly fine. And we'll say private coroutine up routine. This is probably not the best way to code your variables, but this is what we're doing. So then when we start this, we can say up routine is equal to start coroutine, move over time. And we're going to do an oopsie, uh-oh, not good thing on purpose first. And we're going to keep this in update here. We're going to say up routine is equal to stop coroutine. Well, that's not what we want actually. We want to take our value, and instead of just calling move over time and stop coroutine, we want to actually stop up routine now that it's been started, right? And actually, to make this a little simpler, we're going to say input dot get key down, key code dot s for stop, because again, we love controls that make sense. Uppercase S. Okay. So if I pop this into here, hold on. Right. So if we take stop coroutine, now we can stop it on a whim with S once it's been started, right? So, yes. So let's go ahead and try that. So we're going to hit U for up and then S for stop. Awesome. And if I keep hitting S, nothing happens because, you know, we can stop our coroutine. If we hit W, uh-oh, it's not starting the coroutine. Why is that? Well, hold on. There should be some errors here. Because
The screen's still on Visual Studio.
oh, it is? Okay. Sorry about that. Let's see here. Okay. Okay, now we're back to Unity. I wish it could dynamically tell. Okay, so U for up, S for stop. It stops. I keep mashing S to stop. Nothing's happening. It's already stopped. Hit U again. Uh-oh. Well, first of all, it's always starting from that value, so we can play it. But I'm hitting S to stop it, and yeah, that works. Okay. But basically, yeah, you can stop coroutines if you have the variable. Something bad that can happen though, that I'm not sure, I guess it didn't happen, but something you should be aware of is if you try to stop a coroutine before you've already started it for the first time, like before you've set that variable. So like if I try to stop it before it's been stopped, there we go, we're getting our error here. Because we didn't assign that variable, it's null. So don't stop a null coroutine. Just check to make sure it's null before you stop it. Not very simply, just say if this coroutine is not null, then you can stop it, and then you won't get errors. But yeah, that's the power of using variables. So that's about everything in the slideshow in demonstration form. Is there anything anybody would like to see done with coroutines now that we've got Unity open that I didn't necessarily go over in our presentation? Let me get chat open because I'm not sure if, okay. Because if not, that's coroutines in a nutshell.
Question. Wait, am I talking? Cool. I have a question.
Yeah, okay.
Do you make use of any coroutines in personal eyes?
All the time. You have no idea. I could probably even open personalize and you could see all the coroutines. Basically like half the UI is coroutines, if not all of it, like animation and stuff. Character behaviors on coroutines. If I want to move something from place to place, coroutine. If I need a behavior to happen on the timer for like an enemy, like the spider uses coroutines to check if it should move on to its next state or to pause its behavior in the middle of an animation transition. Coroutines are useful for more than just like animation and that kind of thing. You can use them for behaviors, AI, basically anything. Coroutines are super, super useful. They are the backbone of society. They are the unsung heroes of coding to me.
Nice. Cool. Very cool.
Any last questions before we move on to project sharing in Discord? Okay,